Okay, hi there. So I'm just doing a quick video on these two questions that I got asked. It's from the 2014 paper, 1, SEC, so that's just the Examinations Commission sample paper from 2014. To be honest, 2014 papers, I would, if I were you guys, I would be concentrating on the 2015 to the 2020 up. Yeah, I wouldn't be too bothered about it because the paper's changed a good bit since 2014. Anyway, there's some good questions in here I should look at. Now, just there, just looking, there's indices. This is all about indices, okay? Now I have put in here into class notes a summary about, there are rules of indices. There are 9 rules and you have to go through them and you have to try and learn them, okay? There's law 1 and 2, okay? What to happen, when you're multiplying indices, you just add the 2 powers together, okay? And so on. You go through all of the laws and you have to it's not that you've learned them off by heart because you get them in the log tables, but familiarize yourself with them, okay? And then some examples, and then some laws of surds, just 1 page on those, okay? They're square roots, all right? So I put that into the class notes section, okay? Class notes. Now I'll go back to the paperwork section. And let's start answering these. I want to keep the videos relatively short, okay? Now, 6 to the power of minus 2. So you want to, they want the answer here where you know without indices. So we don't want to have the little number. So whenever you have a minus number like that, a minus indice like that, you can rewrite that like this. Put 1 over 6 to the power of a positive 2. So you change it to a positive 2. So you turn it upside down kind of, and you change it to a positive. And what's 6 to the power of 2? Well, that's 6 multiplied by 6, which is 36. And that's your answer. Okay. Now let's look over the other one. 80. Now that's law, that by the way, which law is that? That's so when you have negative numbers, let's go back to the class notes. Let's go back here and have a look at class notes. When you have negative numbers, let's see. So that's the surds. They're just examples. Which law is this? This one. It's law 7. Law 7. Okay. It's all about negative powers. What happens when you have that? And they've examples there for you. Okay. Okay. Sometimes when they're talking about the laws, they use letters instead of numbers, okay? But those letters represent numbers, so don't let that put you off. Okay, the next one. Anything to the power of a half in indices. Anything to the power of a half in indices means square root. Okay, so 81 to the power of a half is the same thing as the square root of 81. You can use your calculator to do that if you need to, but the square root of 81 is 9. Okay, a plus 9 or a negative 9, but you can just write down 9. Next one, express 2 to the power of 24, that's a huge number you see, in the form of a to the power of 10n. So we have to work out what a is, we have to work out what n is. Where, and they tell us then, where a, so where this number is a number between 1 and 10, okay? Including 1, but not including 10. And they tell us that n, the little number n here, they tell us that that is an integer. Okay, so an integer, don't forget, is all the negative numbers, all the positive numbers, and 0. It doesn't include fractions though, it's all whole numbers. Okay, correct 3 significant figures. Okay, so let's have a look at it. Now, from a calculator, you can go to your calculator, put in 2 to the power of 24, and you will get this big number, 16,777,216. That's from your calculator, okay? Now we want to do this correct to 3 significant figures. So we're just interested basically in the first 3 figures there. Sorry, the first 3 figures after the decimal point. But the question is, where does the decimal point go? Well, here's the hint, and this is always the case. It always goes after the first digit. So the first digit there is 1. then your decimal point. Then 3 significant figures. Now it's 3 significant figures, not 3 decimal places. So actually, we're just concentrating on the first 3 figures, okay, like that. So it'll be 1.6. Now, because that's a 7 there, because it's greater than 5, we have to round up this 7 to an 8, like that, okay? And then we're writing it in this stuff like this. So we've the A bit done. This is the A bit, okay? It's a number between 1 and 10, okay, 1.68. Multiply by 10 to the power of something. So 10 to the power of something. So that little n. Well, that's the number of digits after the decimal point. Okay. So decimal point went in here. So how many digits are after that? There's 1, 2, 3, 4, 5, 6, 7. There are 7. Okay. Let me just get rid of those because it's a bit messy. So it's 10 to the power of, instead of n, we put in 7. Okay, and that's it. That's our answer. And again, if there's any issues with this, just because I've explained it here, I understand that that's not always enough. Come back to me and say, sir, I still don't get it, or whatever, okay? Okay, next one. Very, very tricky one, the next one. There's always tricky ones, isn't there, on an exam, but this is extremely tricky. So maybe we should simplify the top line, so let's have a look here. We have to show that this simplifies to that, okay? Now, if someone's going for an A in their exam, these are the only people that I really expect to get this correct. But let's have a look at it anyway. So, and this is all about knowing your surds rule and your indices rules. I think we'll look at that top line first. Now, we can rewrite, let me do it over here, that a to the power of a squared. So I'm talking about this bit, okay? And I'm doing it over here, all right? Now, that's equals to remember, the square root of a number can be written as power of a half. And I'm using a dot there for multiply. So a multiplied by a to the power of a half, okay? Now, when we multiply, that's that a there, so that's this a, that's a to the power of 1, okay? A to the power of 1. Now, you add the powers. That's the first law of indices. So we have to add 1 plus a half, and we get 1.5 basically, or 3 over 2. Okay, 3 over 2. So this bit in the bracket can be rewritten as a to the power of 3 over 2, but don't forget we have this as well. So we have to include that there, a to the power of 4. Now, that top line can be rewritten. When another law of indices is this and this, when you have a power outside another power, you multiply. So you end up with 3 multiplied by 3. So you end up a to the power of 3 by 3 is 9 over 2. Okay, now what we do next is we have a law of indices 2 is when you're dividing. So what's happening here is there's division going on, and whenever you're dividing, you subtract the powers. So we end up with a, and it's the top line first, a to the power of 9 over 2 minus the 4. So on your calculator, what's 9 over 2 minus 4? Well, that gives you a half when you subtract those. And I think, oh yeah, we're nearly done. Remember, we're trying to show this. Okay, now remember that a half is the same thing as power square root of, and that's it. That's a tough question, really, really tough. Maybe towards May, hopefully you'll be getting that type of question, and you'll find out you'll be okay with them. Okay, it's these other ones at the top that you should be trying to get right for now. Okay, let's look D. And again, if there's any questions, ask. Okay, D, this is equally as hard. Okay, this is algebra, but with indices, so a really tough one, this one. I haven't seen them come up this tough since 2014. Okay, what we need to do here is rewrite that. See, the 49 can be rewritten. The key here is to get the same base numbers. Here we've 49 is the base number, here 7 is the base number. Okay, but 49 can be rewritten as, so 49 is the same thing as 7 to the power of 2. Okay, so that we can rewrite that. So 7 to the power of 2, we have the x outside, and we have this. We can leave the right-hand side the way it is. Now, we can multiply the 2 by the x there, because that's one of the laws of indices. So 7 to the power of 2x is equal to 7 to the power of 2 plus x. Now, because we have the same base numbers now, we can just ignore them basically and just concentrate on the top lines. 2x is equal to 2 plus x. Now, this is algebra, so we need to get everything to one side, okay? And get 0 on the right-hand side. So what we might do is get everything to the left-hand side. So we've already got 2x there. Now, bring over the 2 there. So 2 comes over, but becomes a negative 2. Change the sign. And the x comes over and becomes a negative x. You just change the signs. You're basically subtracting 2 from both sides, and you're subtracting x from both sides, so that we have 0 on the right-hand side. Now, we can tidy up a bit here. We have x minus 2x minus x. Well, that's 1x. We're just left with 1x. Minus 2 equals 0. Now, we want to get x on its own on the left-hand side. So bring over that minus 2, it becomes a positive 2. And there's your answer. Once you have x on its own, you're done. So x is on its own, and the answer is 2. Okay, brought that over to here and changed the sign to a positive. Again, very tricky. I'm going to stop the video at this one, and I'm going to record a second video for the other question.